Hello and welcome to today's special event, Implementing HCI-centric Database as a Service for Cloud-like Agility. Thank you for joining us on today's event. Thank you for taking time out of your busy schedule. I hope that you enjoy the event and learn a lot. My name is David Davis. I'm excited to be the moderator on today's event. We've got a really cool event lined up for you today. Now, today's sponsor is Robin Systems, and this event is produced by Actual Tech Media. Before we jump into it, there's a few things that you should know about the event. We want this to be a very educational event, so we encourage you to use the questions box in the GoToWebinar control panel there to ask as many questions as you'd like. We'll have a dedicated Q&A session at the end of the event to answer as many of those questions as we can. So keep those questions coming in throughout the event. We'll be answering them all at the end. Now, at the end of today's event, we'll also be giving out a $300 Amazon gift card to one lucky attendee on the live event. If you're watching this event on demand, the recorded version of this, I'm sorry, the live drawing has already passed. If you're interested in the legal prize terms and conditions related to that drawing, you can visit actualtechmedia.com. Scroll to the bottom of the page, and there you'll find our prize terms and conditions to be eligible for that drawing. Now, with that in mind, I'm excited to introduce you to today's presenter. I'm glad to welcome Mr. Rob Martin. He is a solutions engineer at Robin Systems. So let's talk about what we're going to cover on today's event. We'll kick it off by helping you to learn the essentials of running Oracle using clustered containers on Kubernetes. Some really cutting edge cool stuff here. Then you'll see a live demo of database lifecycle management at the push of a button. You'll receive an introduction to the Robin Hyper-converged Kubernetes platform, and you'll learn how real companies are leveraging Robin to do some really amazing stuff. And with that, I'm excited to hand it off to today's presenter. Welcome, Mr. Rob Martin. Thanks for being on, Rob.
Yeah, thanks, David. Thank you, everybody. Welcome. Good morning, good afternoon, wherever you may be. So I just want to start out real quickly. We often are asked, what is this hyper-converged Kubernetes, right? Are you guys are you a hardware vendor? Are you, I understand hyper-converged infrastructure. We've heard of Kubernetes, or maybe we're working with Kubernetes a little bit. This term is something we've coined. I mean, we're unique in the industry in that we are the first to have actually brought the simplicity and the economics of hyper-converged infrastructure, and we've married that with the speed and agility that Kubernetes brings to the table with respect to provisioning very rapidly containers on behalf of various application workloads. And so we're the first to have done this, to have brought all this into a single unified platform. Robin itself is a software-only stack. It's a software-defined application orchestration framework that brings its own software-defined block storage along with the virtualized networking layer with the compute layer. And then around that, we've wrapped a very unique provisioning workflow where a lot of the secret sauce actually resides with regard to just how we are able to provide a platform where you're able to let the application drive the infrastructure, right? So it's all about abstracting all the complexity associated with standing up infrastructure, all the time required to do that, the long request approval pipelines associated with having to get all that infrastructure stood up, and the complexities associated with that, the pitfalls associated with that, and letting the application drive all that in an automated way, in a very predictable way. So, virtualization, right? When we look at the modern business today, I mean, the modern business basically is driving the needs to be able to deliver new products, deliver new capabilities of existing products much more faster than ever before. The innovation windows are shrinking, right? As companies are really striving to try to remain competitive, to really draw out their differentiation among their competitors in the industry. So hence you've got the whole DevOps movement, right? I mean, you've got the whole continuous integration, continuous delivery model, having moved from the traditional waterfall approach to application development and into more of an agile approach, where release cycles are compressed. You've got typically this notion of a 2-week release cycle, having to really churn out product on a much more continuous basis. And when we look at what that means for the database folks, right, for products like Oracle, the impact that this movement has had. We look at the developer community, right? The developers, essentially, they need much faster provisioning. They need to much more quickly, much more rapidly and easily, stand up dev test environments through refresh cycles from their prod environments. From a QA perspective, QA is kind of sitting on the continuum between dev and the operational side, the prod side, right? So you've got this idea where QA is typically needing to do similar types of operations. They're needing to replicate stacks from dev test to do their do their jobs, right? To QA, to qualify the product prior to it being promoted into production. And then conversely, they're having to kind of play the other end of that, where they're having to as issues arise in production, they're having to there's a need there to be able to very quickly replicate stacks as they're in prod, as those issues have been discovered, to very, very easily provide that back to dev test to perform the kind of troubleshooting sort of bug fix type type work that they do. So from an operational perspective, it's very similar, right? The ops teams need to be able to accommodate this very high frequency of provisioning and deprovisioning throughout these refresh cycles. And overall, IT is striving to try to keep costs under control. The whole TCO thing and ROI thing is very significant. There's a lot of pressure on IT to manage this. And as we look at these various scenarios in the previous bullets, of course, we're almost invariably looking at unnecessary data sprawl. We've got multiple copies unnecessarily being spread around the enterprise, and unnecessary costs ensue from this. So if we look at the traditional model today with respect to Oracle, and we look at the typical request approval pipeline relating to somebody in the organization saying, okay, I need to stand up an Oracle database. Well, what does that person typically need to do? And obviously this depends on how structured the business is, the company is with regard to how it does this. But quite typically, we find this scenario where the developer, whoever is the consumer of that, needs to first submit probably a request, right, of the manager. The manager has to go and approve that. It gets forwarded to the DBA, and this, of course, is where the real work happens. But there's a forwarding that has to happen here with regard to having to, provision the hardware and the storage. Even if it's even if it's already a virtualized environment, there's still some provisioning, of course, that has to happen with respect to provisioning the VMs. And certainly the storage equation doesn't really change there. So then it goes to the storage manager, right? With Oracle, depending on how sophisticated that deployment needs to be, if it's rack, right, the whole mechanics for doing that provisioning of the storage is going to vary slightly from a non-rack environment. But the bottom line is the request ends up sitting on the desk of the storage admin, who then has to go and do all the LUN, carving and masking and presentation to the node or nodes, which the sysadmin has perhaps already provisioned. Then you've got the networking side, right? From a rack perspective, there's lots of little nuances here for those of you who are who have already adopted rack. You understand the additional complexity here, and only then can the DBA actually make good on that request that's been presented to him by being able to provide that environment for the original requesting user. Okay, so in today's world, in the DevOps world, in that sort of model, all of this arguably has to happen within just a few days. Okay, so I mean, this is a lot to get done in just a few days, when it's not at all uncommon for it to take weeks just to get this portion done. And if you're actually trying to procure hardware as a part of this process, that can turn it into months. Okay, so arguably within a week or so, you've got to be to the point where your developer has already done whatever it is he was trying to do to build out a new capability, a new project in general, to be able to then hand that over to QA, right? So then QA does its qualification process, so that within a couple of weeks' time, you need to be able to meet this need, to be able to produce that to promote it into production. So the answer is to build out a very agile sort of DBAS type type offering internally, so that IT can empower its end users, its consumers of the Oracle technology with their own self-service provisioning, to be able to do that very rapidly, do it very simply, right? For the management framework around that to be greatly simplified. IT is looking for some sort of standardization across various platforms. They're obviously looking at managing costs, both the hard costs as well as the soft costs around maintenance, and providing better support to those end users, the developers perhaps. And so in general, it's about managing costs, again, both hard costs and soft costs. So the fundamental business requirements, it kind of comes down to time to value, right? Being able to meet those demands that the business has to remain competitive, to establish differentiation in the market, and with that comes, from a business perspective, the need to keep costs under control and to really provide a future-proof sort of platform for innovation. Okay. So how can we help? What does Robin do, right? So Robin, through a very intuitive managed service-like experience, through this notion of an app store portal, Robin enables deployment of your Oracle databases much faster than you would be doing today. Certainly much faster than the very traditional bare metal type approach, but even faster than the arguably more modern virtualized VM type type paradigm. So we're talking about being able to do this type of operation faster by as much as an order of magnitude. Okay, and being able to do that largely by way of empowering the user with his or her own capability for standing up any Oracle database, including RAC. Okay, cloning, right? So when we talk about the refresh cycles and the challenges that poses on the DBA, not so much from a mechanics perspective. A lot of seasoned DBAs are very comfortable with doing this on a very regular basis, but it doesn't change the fact that it's very time consuming. And so to be able to do this very nimbly, at the drop of a hat, on request, or perhaps even again being able to empower the actual users, the developers, with their own capabilities around doing their own cloning, their own refreshing. Consolidation, right? So containerization brings with it a great deal of opportunity around densely packing more into less, and but unfortunately with that comes significant challenges around managing resource utilization, right? You've got the notion of the noisy neighbor effects, resources being overconsumed, workloads stepping on one another, and so there must be something in place to ensure that these workloads will play well together in the same sort of grid type infrastructure. Okay, being able to remain elastic, right? Being able to dynamically scale up, scale out, scale back down, to be able to trade computing and memory resources across the landscape of the different applications that are participating in that physical cluster. And then there needs to be obviously an element of HA, right? So even for those folks who aren't using RAC, there needs to be some element of high availability, and so Robin is, of course, through containerization and this notion that in the Kubernetes world, there's always this goal of maintaining a desired state for any given pod that's in the cluster, and therefore even a non-RAC Oracle database benefits from this through being able to be automatically failed over, so to speak, to a surviving node in the Kubernetes cluster. And then finally, bringing predictability, bringing ease and speed around the upgrading and the patching process, right? With the ability to do this while minimizing downtime. So it looks like, do we have any questions?
We have some questions coming in. We're going to save those to the end, but I just want to remind everyone else, if you have questions about HCI, Kubernetes, and running Oracle in Docker containers, get those questions in, and we'll be asking those as soon as we start the Q&A session.
Okay. All right. Well, let's so let's get into the first area here with regard to self-service provisioning. So, as I said, Robin presents this portal, a very intuitive App Store-like interface for the consumer of any application, really. Today, we're focusing on the Oracle database, but really, Robin's focus is to bring Kubernetes to the masses. It's about making Kubernetes a viable virtualization platform for all applications, not just the stateless apps for which containers, arguably are most suited, right? This is actually, what containerization was initially intended for, but it's about bringing this to the stateful community, right? So, so through the interface, then essentially what you do is you just click on one of the, the Oracle application in this example, and upon doing so, and we'll talk about how this works here on the next slide, but we're going to present the provisioning workflow begins, right? So, here, this just happens to be the workflow that would be associated with provisioning a rack database. So as you can see, we have the ability to specify the number of rack nodes that we want. This just is sitting at 3 instances, but this can be tweaked as desired. We give our application a name, we specify the public and the private interconnect, and we specify some other inputs around storage. And really, it's just a matter of clicking on provision. And then behind the scenes, Robin takes care of all of the automation of all those Kubernetes components, all those resources, and all the plumbing of those resources, both from a storage perspective on up through the networking stack. We provide the user a lot of flexibility around the networking stack through a choice between either Calico or Open vSwitch for that network virtualization, and then finally the compute piece through Kubernetes orchestration in deploying, quite typically in the Oracle world, and especially with regard to rack, an LXC container or a set of LXC containers, Linux containers. So Robin actually supports both Docker and LXC containers and treats them very much the same with regard to how they are bundled, quote unquote. I overuse that term because that's actually the term that we use for these applications as they're presented in the App Store. But upon clicking that, then all of this is driven automatically in the context of the application, as tweaked through the provisioning screen, upon whatever inputs are needed by the user, and you literally have an Oracle database deployed, a whole new Oracle home stood up, and the database automatically created on your behalf. So how does this work? So behind each of those buttons on that in that portal is a couple of things. One would be something we call a manifest file. And if you're familiar with Kubernetes, this would be somewhat analogous to a Helm chart. The one big difference here is that in Robin, everything needed to specify that orchestration, to specify the behavior, all the behavioral characteristics and the functionality of the application as it relates to perhaps snapshotting, cloning capability, whether or not it can be scaled up, scaled out, all these characteristics can be baked into this one single manifest file, and it's a YAML file, as opposed to in Kubernetes having a whole series of YAML files, one for each type of Kubernetes resource. And the other thing that's contained in this bundle is a set of hook scripts, and this is really wherein lies a lot of the power with Robin is through its extensibility. The bundle concept is a very open concept. And of course, again, today here we're focused on just Oracle, but there's no limit to the types of applications that can be embodied in what we call a bundle. And so the hook scripts essentially define that behavior. It defines that behavior upon, for example, the initial provisioning of the application. Here you're gonna have the database creation process, starting up the instance, mounting the database, opening it, etc. All that's going to be part of part of these hook scripts. You're also going to have some things that you're going to want to do when you perform certain lifecycle management operations, right? You might need to quiesce the database. You might need to, do certain things if you're getting ready to patch the database. And so all this behavior can be shaped as part of these, part of this collection of hook scripts. They're typically written in Bash and Python. And so this is how you kind of define the application and everything that it's able to do. Okay, so let me just I think, yeah, so let's jump over to the product here, and I will show you what it looks like to actually provision a RAC database. Okay, so when you first log into the console, this is what you see, the dashboard. I won't go into this in great detail, but what you typically do is you're going to jump straight into your applications and then your bundles. And so this is that portal that I mentioned that you saw in the presentation. And this just happens to be some bundles that I've added to my cluster. This is in no way a full representation of all the reference bundles that we have available. And these, by the way, are just simply provided with the product. They're provided as a reference for customers either to use as is or as a basis for, for modifying. You can create these from scratch. We provide training on all the nuances, the details of how to actually author these bundles for any sort of application. And the point I want to emphasize again about the extensibility and the openness of the concept is that, here we just basically have some out-of-the-box reference bundles here, but we have customers that are interested in packaging together, an entire stack, not just the database, but perhaps packaging the database along with, say, a WebLogic tier, with any number of WebLogic containers as part of that deployment. And all of that can be encapsulated in this bundle. And in doing so, that entire stack is able to benefit from all the lifecycle management type functionality that that we're going to go into here shortly. But so basically, as I look at this, then I come in and I want to deploy a RAC database, and so I would just simply click on this, and you saw a sample of this in the deck. I would just simply give my application a new name. And as a lot of you are probably aware, again, RAC has its own particular requirements, and so I would need to specify both a public and a private interconnect. I have all this defined already as part of the infrastructure that comprises the actual Robin cluster itself. So in other words, I have a 3-node cluster in this example. All 3 of my nodes have 2 NICs. These networks have been defined and configured there. So then from here, this is just as it currently sits in the manifest.yaml file. I've got defaults. This just happens to be defaulting to 2 instances. I could deploy as part of this initial provisioning operation any number of RAC nodes I want. I can specify all the the compute, the memory, et cetera, and then obviously here down in the storage. Some of you, I almost forgot, and some of you RAC folks may be wondering, well, what about the scan? So I've actually defined a scan resource to Robin already, and I would just simply select that here. Obviously, you need to reference the scan in order for the grid infrastructure to install successfully. And then one of the things that's really interesting about Robin and where we really differentiate ourselves from the other Kubernetes distributions is that we allow this very granular control around the placement of the pods on the physical cluster nodes. Okay, so in RAC, for example, when you deploy a RAC database, in this case, I only have a 3-node cluster, so I'm probably not likely to be deploying a 4-node RAC database or a 5-node RAC database, right? But for my 3-node RAC database, I don't want to be putting two instances on the same node, right? So I can control that, right? I have a rule here that I can say I want to ensure that I'm not going to place more than 1 container. In this case, that's going to be synonymous with my RAC instance on the same node. I might also want to enforce that storage would be co-located with that compute, with that instance. I might want to really get clever and tag my nodes with just a name value pair tag that can be assigned to a particular node. I might have some, maybe I have a 16-node cluster and I've actually reserved some nodes just for RAC. And therefore maybe I've tagged them with a particular tag, and I can actually specify particular tag to be able to say that, okay, I'm only gonna deploy these resources on those nodes with that particular tag. So I have a lot of control here, and depending on the application, again, this is Oracle RAC specifically, so I have a certain set of relevant rules here. this starts to get really interesting when we look at the more complex ecosystems like Hadoop ecosystems. You know, Hortonworks, for example. I've got twice the number of placement rules available to me, because now I might want to look at, you know, I'm getting off track here, I guess, but I've got the ability to enforce where certain components live, where they may be co-located. So I've got node affinity and node anti-affinity control, as well as some of the things that we're doing here in the context of RAC. So at this point, I mean, I've done everything I need to do to be able to deploy this RAC database, and I would just simply click, you know, provision application, and then we would be off to the races. And it just so happens on this particular demo cluster, it takes just shy of an hour to actually fully stand up this this RAC database. Okay. If you find yourself going in and on a regular basis making tweaks to these default changes, you can also save those off as a template. So I had that button down here. I had the option to save everything that I defined in here, the scan, all the storage input, everything, and specify a template. And so when I pull this up initially to go provision it, I could simply, you know, specify that, and then I'd be off and running. Okay, so in this case, I actually have a RAC database that I've already created. I actually have a couple here. I also have a single instance Oracle database out here. And so when we go out and we actually look at one of these, we pull it up. We can actually see all of the containers, and I can see that they're LXC containers. I can see where each of these, again, each of these is a Kubernetes pod. I can see where these pods are living in the physical cluster. I can see, again, I have a 3-node cluster. These are 2 of those nodes in the cluster. And I can see how much compute and how much memory has been reserved for these particular containers. I have physical IP addresses that have been assigned to these pods, and so I can access these right already. You know, as soon as I've deployed this, I can access these containers and therefore get into the cluster. From an Oracle perspective, by simply SSHing into these and doing whatever it is that we need to do. So that's, I mean, in a nutshell, that's kind of, I mean, that's really all there is to it in standing up, in this case, an Oracle RAC database. And again, as some of you are probably aware, this typically, would take probably a good week particularly for folks who don't already have the infrastructure already built out, and or are already familiar with all the nuances of RAC, the networking requirements for the interconnect, the storage, the shared storage requirements, et cetera. And so, this is just simply a matter of building out this hardware ahead of time, and then thereby providing a platform, a virtualization platform through Robin for very easily, being able to stand up something as complex as Oracle RAC by having pooled the storage, the networking and the compute, and providing all the necessary, prereqs for this particular stack. Okay. So let me jump back over here then and move on to the next section, which is going to be about the challenges associated with refresh cycles, right? So today, the traditional method is, unless you're looking at some sort of third-party product that actually does some of the things that Robin does around mitigating some of the issues around this particular type of processing, you typically end up with with data sprawl, right? So every time if you look at what a refresh is, right, you're typically looking at cloning from production. You're often wanting to first create a test master because you don't want to be continually cloning directly off your production database to in order to minimize impact on that production instance. So you would first typically instantiate a test master from which you would start to then run clones and do continual refreshing of various other copies of that data, those databases. But in doing that, right, for every time you do this, starting with the test master clone, you're doubling, tripling, as a function of however many of these instances you need to replicate out there. You're creating or you're consuming that much additional storage. Okay. Obviously very taxing from a storage consumption perspective, costly, et cetera. So, and remember, we're about trying to meet IT's needs for reducing those types of costs as much as anything. So, well, what if you could actually create as many of these as you want without incurring all of that penalty, right? So, of course, we're talking about copy on write, right? Copy on write snapshotting capabilities. A lot of you are probably familiar with this concept. It's certainly, the concept itself is nothing new. A lot of the storage, pretty much all the storage vendors are doing this. But it's the notion of being able to create a so-called copy without incurring all the additional storage, without fully replicating all the data blocks. Okay, we're only replicating the headers, and then we're tracking changes, right? So we've got this notion of a copy, which is really little more than a series of pointers back into the original data blocks. And so only when we make a change to those source data blocks do we actually materialize any sort of data, so to speak, in the in this snapshot, in this copy. Okay, so greatly reduces the amount of storage consumption, the amount of real estate that we consume out there in the storage subsystems. Thereby reducing costs. Okay, so what we do then is we leverage that to do thin clones. Okay, in Robin. And so, and again, I want to kind of reiterate, everything that Robin is doing is in the context of an application. So we talk about snapshotting, we talk about subsequent cloning from those snapshots. It's all about the application. It's not just simply about the data. So all of this is in the context of the entire stack, everything that is represented in that bundle. This is where the value in being able to maybe encapsulate more than just a database, but maybe multiple databases. If you're trying to keep them all, if it's a distributed type database, landscape, you may want to keep all those together. They're kept consistent, consistent point in time, and you're able to more holistically apply a lot of these lifecycle management operations, on the whole that way. But so in this case, we've got our snapshotting on which we're basing this thin clone, and so we've got this time consistent copy based on the copy and write technology, and then so then on top of that that snapshot, then we're actually cloning the so-called application, right? So this is obviously going to be the database home. On top of the database home, everything that's sitting on disk, it's going to be the actual instance, all the processes and such for actually being able to obviously interact with that, with that data. So therefore, we've got this opportunity to create, we can clone and clone and clone again, and at just a fraction of the cost from a storage consumption perspective, right? So we can just create as many of these as we need, through thin cloning, only consuming really just a very small sliver of that which we would have otherwise consumed through more traditional means. Okay, so let's just take a look at what that looks like real quick. So for our rack database, right? So here we've got our rack database. I would just simply click on this Manage tab here, and I've already created a snapshot here, and I can have as many of these snapshots as I want. I could have created a snapshot schedule upon the initial provisioning. Y'all might have noticed that. So you could set this to be for snapshots to be performed every hour, once a day, certain times, etc. And so you got some power there. But what I would do is, I might, let's say I did have a whole collection of snapshots. Well, I might want to be looking for a particular one. Well, in order to make that determination, I need to know what that snapshot consists of. So if I click on that snapshot, I can see, let's say I specifically am looking for that snapshot where I had 4 cores of compute and 10 gigs of RAM across my rack instances, right? Because over time, I may have evolved that to where maybe I grew that. Maybe I had, at some point in time, I had scaled that out to 3 nodes. Well, I need to get back to this point where it was a stable point in time where we had these 2 nodes and it was configured in just such a way, right? So I can identify that. And from there, then I can, sorry about that. And so from there, I can go back and create that. Sorry about that. I can create that thin clone, right? So I go to the particular snapshot I want to use as that basis, and then I can come up here and I can clone that. And again, I get not just the storage volumes as we've sort of illustrated on the previous slide, in the way that's done through through copy on write, but I have the entire Oracle stack sitting on top of that storage, ready to be utilized. I can share that. If I'm QA, I can share that back with dev or prod. I can clone the prod environment and provide that back to dev to do whatever troubleshooting they may need to do, and it avoids that pitfall where if we put the onus on development to have to, by just giving them the data and having to build up that entire stack on top of that and hope that it's in fact the exact same stack, same version, everything as the problem was encountered on in production, there's risk there that we're not going to hit the problem or be able to reproduce it, right? So there's a lot of value in being able to do all these types of operations, again, in an application context, being able to provide that entire stack. Okay, so I could restore back to this to roll back. I can in the context of this here, we would create that thin clone. Okay, so that's pretty much how we would do that. It's that easy. Snapping is just takes a matter of a few seconds, and then creating a clone is typically it takes a fraction of the time that it takes to create that, do that initial provisioning. A lot of which is based on some of this technology that we've just been covering with regard to copy on write. Okay, so let's talk about quality of service and being able to define and meet service level agreements. Okay, so as I said, consolidation brings a big promise around, or containers rather, I should say, bring great promise around dense consolidation, much more so than VMs, right? Containers are much lighter weight. Not only can they be provisioned and deprovisioned much more rapidly, but the reason for their advantage there is the same reason why they are just inherently smaller, right? So you've got much more dense packing available from a consolidation perspective. But in doing that, you're opening the door for resource contention. And Kubernetes itself doesn't really provide any built-in resource management framework. And so mitigating those risks of the noisy neighbor effects is very challenging. And you have this across the entire plane, right? You've got it from a compute perspective, memory perspective, networking, and I/O. And if you're some of y'all may be using Exadata, and so you're very familiar with the needs when consolidating multiple disparate workloads into an Exadata machine. You need this capability for fencing things like I/O, for being able to control I/O resource utilization across these different different workloads across these different databases, and Exadata certainly provides that. And in fact, Oracle provides that with the database across a couple of specific storage solutions outside of Exadata. But Robin is bringing this to the masses, right? So Robin is actually bringing all this capability to commodity infrastructure. All right. And so what we're doing here is several different things, right? So first of all, there is the capability to define what we call resource pools. So you can fence the hardware resources within the cluster. You can carve out the cluster to have, let's say you have a 16-node cluster. You could have a non-prod, 8 nodes dedicated to non-prod and 8 nodes dedicated to prod, thereby guaranteeing that no production workload, because any production application is going to be deployed to a specific resource pool, the prod pool, for example. You're guaranteed that no such related resources would ever get provisioned on any other resource pool. So there's physical demarcation there that's possible. But then there's also the ability to do some really interesting things around quality of service. So this is this is Robin's own block storage stack. We manage the entire I/O path from the application tier all the way down to the storage volumes, the Robin storage volumes. We tag I/Os with metadata that identifies the application issuing the I/O and the storage volume to which that I/O is destined. So by that, we're able to allow the administrator to define IOPS minimums, right? To be able to guarantee on a per application basis, right? In other words, for this particular database, as it's been deployed from this bundle, on a per volume basis within that particular deployment, we can guarantee a minimum number of IOPS. We can also cap IOPS. So as we apply these different rules across the landscape of all those various applications, we're able to bring a very strong element of performance predictability across these different these different workloads that are deployed in the same shared shared environment. Okay. So what this allows us to do, one opportunity that it opens up for us, is to be able to to do things that we might not otherwise be able to do. So we can, in fact, do something like run production and dev test on the same shared shared hardware, right? We can do clones from a production environment, have that clone stood up in the same infrastructure, even if it's in the same resource pool, right? We still have the capability for governing the I/O, right? So we're actually, we're actually allocating dedicated I/O channels, so to speak, here on behalf of each of these different workloads, and so we're able to to provide throttling of the I/Os from one application over the other. So in this case, obviously providing additional priority for production over non-production. Okay, so again, another thing which is not available with any other containerization solution, and being able to do yet another type of management type operation very strongly in the context of the application workload itself. Okay. So let me just show you what that looks like real quick. So if we were to actually look at, again, going back to our rack database, I can come in here, and if I click on this QoS button here, this is where I've got, for my rack database, I have the ability, in this case, I'm on the data volume, and I can set minimums. I can say I need to be able to guarantee, 28,500 read IOPS and 55,000 write IOPS. Maybe I want to do the same thing over here for my flash recovery area. Maybe accordingly, right? So as I said, on a per volume basis, you can do all of this type of control for that for that particular application. Okay. And then I would just simply apply that, and then it would make the necessary adjustments, and that's also a pretty, like snapshotting, that's a pretty quick operation. All right, so let's move on to scaling. So being able to dynamically, very elastically, adding and removing compute memory, and in the case of rack, being able to do that, in the context of rack, being able to add and remove nodes from the cluster is naturally very important to be able to dynamically meet the business needs. And so when we scale up in rack, when we scale up with any application, really, it's just simply a matter of going in and, again, tweaking the quality of service settings and adding compute, adding memory, or conversely, just as easily being able to pull to take away compute and or memory from that application. We actually have some automation at the command line that even will be able to do this type of operation in the context of multiple applications. So identifying that maybe I have two main applications out there, and one peaks during the day, the other one peaks at night. And so there's a way to very easily and programmatically through the API being able to trade those resources between, swap them between those different applications. From a rack perspective, in addition to being able to scale up and scale down each individual node, we can scale out, right? So same thing. We've got scale out and scale in operational capability here by being able to dynamically grow and shrink the cluster. Very easily done, again, by way of the same interaction here. One of the things that we try to do is present a very consistent workflow, regardless of the application, regardless of the type of operation that's being performed. So this whole interface that you're looking at right now, for example, the screen is going to look the same regardless of whether it's Oracle, Hadoop, anything like that. So we would provide these settings here in very much the same way. If we needed to scale out data nodes in a Hortonworks cluster, same thing. So in this case with rack, we want to add a third rack instance to the cluster. So we just simply click on scale out, say maybe we want to add 2, add 4, add 7, which we obviously wouldn't do on our 3-node cluster, but we have this capability for just at the with the click of a button being able to scale that do that scale out operation. So all the typical prescribed operations that are associated with scaling out a cluster, creating the new instance, the additional thread of redo, registering it with CRS, all of that is embodied in that bundle that we talked about in the manifest, and then in the hook scripts that are also associated with that. Okay. So failover. So again, containerization is, particularly in the Kubernetes world, it provides inherent HA, right? So here specifically, we're talking about the fact that for non-rack, for example, right, you obviously get built-in HA with rack, but even for non-rack, we're going to monitor the containers, the health of the pods in the cluster, and in the event that one fails for whatever reason, or if a physical node underneath that pod fails, and that pod has a desired state of being up and running at all times, and so therefore Robin is going to take care of automatically relocating that pod, starting it back up on a healthy node, surviving node in the cluster, right? And we'll take care of automatically, moving the data volumes over, and mounting that appropriately, so that obviously the database can be opened by the newly started instance as it's now started up on another node in the cluster. Okay. All right. So. Yeah, I don't actually have a demo for that, so let me just keep moving, especially in the interest of time. I know we're up on 10 minutes left. We want to try to leave y'all room for some questions. Patching and upgrade. So again, this is just, conceptually, we leverage a lot of the stuff that we've already been talking about, right? The whole notion of copy on write snapshot, being able to do this very efficiently, being able to then, we create a thin clone on top of this. What it does is it's allowing for, you naturally want to test your process first. You want to apply a patch or upgrade the database. You want to test before you roll it into production. The challenge there, of course, is being able to do that very easily and quickly. It's a very similar challenge associated with doing the initial provisioning. And so we're exploiting all the same qualities of the platform to be able to do that. So it's really just a matter of going through that snap and cloning operation. Now we have our exact clone. This is where we would apply our patch, right? So we basically, we log directly into the container, and we would apply that patch, do whatever testing we need to do. And once we're satisfied that everything works and we've done all our necessary regression testing, it all works great, then at that point we know that we can apply that patch to production, with confidence that it's not going to, we're not going to have any kind of regression in performance or break anything else. Okay, so we would do the exact same thing. We'd log into that container, apply the patch, and and we're off and running. Okay, so again, I mean, Robin, we talk about this notion of hyper-converged Kubernetes, right? Robin has solved a lot of these problems, these fundamental issues associated with deploying data-heavy applications in Kubernetes. There are technological gaps with respect to deploying these types of workloads in Kubernetes. Robin has closed those gaps. It's also equally important. We've abstracted all the Kubernetes complexity. We're driving all the deployment and the plumbing and the wiring of all those Kubernetes resources on behalf of that consumer, on behalf of that person who needs to stand up that Oracle RAC database, for example, or any other workload. And so there doesn't need to be any sort of, you don't need to be a Kubernetes practitioner to leverage all the benefits that Kubernetes brings, and to be able to do that for your Oracle workloads. We're doing this for a number of customers. We have we're doing this across a number of different industries, different types of workloads. One of the biggest ones that we tend to showcase is a pretty large leader in the travel industry, technology service provider in the travel space. These guys are running hundreds of Oracle RAC databases on a single Robin cluster. And one of the big benefits for them, and one of their main objectives, was to be able to provide their end consumers of the Oracle database and RAC database technology with their own self-service provisioning capability, and also a lot of the ongoing lifecycle management tasks, like the snapping and the cloning and things of that nature. But we've got customers running other workloads as well in the Hadoop space, log analytics space, as well. So really, in summary, it's from an IT perspective, it's about improving the ROI, lowering CapEx, being able to do more with less, right? Being able to really promote optimal utilization of those hardware resources, being able to do it without the risks of having resource contention, right? Being able to really meet the SLAs and still address some of those high cost type things that ensue, as the organization grows. We didn't talk a lot about multi-tenancy, but there's a rich role-based access control framework within Robin. We talked a little bit about it, I guess, through resource pooling, but on top of that, you can build out capabilities and quotas and so forth on a user basis, a tenant basis, to be able to provide a lot of fencing within the cluster to provide isolation for a number of different types of consumers. From an app DevOps perspective, again, agility is the name of the game. In the Hadoop space, for example, being able to do a lot of clever, creative experimentation, being able to very quickly stand up and tear down clusters to connect to an HDFS, back end, being able to try different things and so forth. Oracle's the same way. I mean, the ability to provide that basis for collaboration across development, QA, prod, and to do it without the penalties again of these different organizations stepping on one another. Again, overall maximizing resource utilization while still preserving predictable performance across the landscape. So with that, David, that's pretty much what I had. I guess we can open it up to questions or.
Yeah, absolutely. Yeah, great presentation. Really appreciate that, Rob. I love the demos, switching back and forth between the demos and the slides. We do have some questions here for you from the audience. If you're out there in the audience and you're wondering about hyper-converged Kubernetes and how how you might run Oracle on the Robin platform, now's the time to get those questions answered. So just enter them in the questions box. Let's see. First question. I think you covered this right at the very start, Rob. Is this hardware or software?
Yeah, so this is a software-only stack. So Robin is actually a CNCF certified Kubernetes distribution. So, without naming any of our competitors, that you could simply go out to the Cloud Native Computing Foundation and find 50, 60 some odd, or much more than that, I guess. In fact, Kubernetes distributions. We're certified on 1.11. We do encapsulate everything that you need to support any workload, any deployment of any type of application, whether it be stateless or stateful, on Kubernetes through nothing but Robin software running on commodity hardware with direct attached, locally attached storage.
Okay, so this is a Kubernetes distribution, and is there some sort of hardware compatibility list? I mean, how do people know what hardware they should or should not use to run this?
Yeah, so we provide that. I can tell you right now, it's essentially any x86 hardware running either Red Hat or CentOS, and well, for that matter, Oracle Linux on those physical machines. From a storage perspective, as I said, it could be something as simple as direct attached, commodity disk, whether that be flash or spinning disk. We also naturally support SAN and NAS. We actually have a partnership with NetApp right now, for example, whereby we exploit NetApp's ONTAP API for the provisioning of storage in the NetApp filers, and we're actually working with additional vendors as well, Pure being one, for example, to provide similar capability where we're actually exposing their own native capabilities through the Robin interface when provisioning out that storage. But that's basically it. I mean, the only other thing I think of note would be the types of workloads that we support today are Linux workloads, right? So those of you that are running Windows-based workloads, it is on the roadmap. We're very shortly going to be supporting containerization of Windows workloads by way of KVM. But today, we're talking about any Linux workload running in Robin.
Okay, and in terms of applications, I mean, you talked here about Oracle and a number of other databases. Is it primarily databases that I would run on Robin, or could I run, containerized web servers or any other Linux-based containers? Yeah,
any container, any Docker or LXC container image can be used. So what that says is that it doesn't matter what's in that image. I mean, I have, as a matter of fact, well, I guess I do just have, I mainly do have data-heavy applications for which I've loaded bundles. But you can see, I mean, I've got Hadoop stacks. Well, I don't. Yeah, I do. I have a Hortonworks bundle that happens to be loaded here. Splunk, Kafka. So it's definitely not limited to databases. And again, it's not limited to any single instance of any one of these products, right? So it's all about how the bundle is built. So you can compose much more sophisticated stacks through simply encompassing those images into the bundle, and then all the necessary hook scripts and such to to bind all that together and to ensure that it'll come up together, it'll be quiesced together, all these various things that might be relevant through the life cycle operations of that particular set of products. But yeah, there's no limit to what can be bundled. Very
nice. So this is a Docker containerized. I mean, this is a platform for running Linux containers, really. It just so happens that databases are one of the big primary use cases.
And that's simply because it's been traditionally very difficult to support the needs of an Oracle or any of the stateful workloads. And Oracle just happens to be a classic case of something that's been a very difficult problem or set of problems to solve with respect to containerization. You have things around storage state management, network state management, IP address persistence, things of this nature that have traditionally, meant that containers and Kubernetes have generally been kind of prohibitive, in support of these types of applications. Things like preserving changes that are written to the root file system, right? So typically with containers, you're going to lose any changes that are written to the root FS. That could mean that the application itself could lose data upon restarting of that container. Robin has its own implementation through a graph driver, its own overlay FS implementation that preserves all changes made to the root file system, right? So we've really been a leader in this space. We've been around for about 5 years or so, getting a lot of press. Most recently with the whole wave of Kubernetes interest and so forth. Folks are really showing a lot of interest in moving not just those stateless type workloads, but the data-driven application workloads into some sort of container platform, and so we're very well positioned in that regard.
Very nice, very nice. I know we're running out of time here. If you go back to the slides, I know you have a final slide there with some more information on what people should do to get started, and I also want to announce our prize winner. So. Let's see, today's prize winner, the Amazon $300 gift card, is going out to Timothy Batten of Tennessee. Congratulations, Timothy Batten of Tennessee. And what should people do to get started, Rob?
It really is no more difficult than going out to our website, and you can contact us there. And I don't have a slide with the link or anything, but if you go out to robin.io, and it's very easy to contact us here. We're a very nimble organization. We're very eager to, quite typically, without getting into the nitty gritty, a typical sales cycle for us does in fact include a POC. So, don't hesitate to show some interest, and let's talk about your use cases and get that stuff documented with some success criteria, and we're happy and always willing to engage in actually getting this stuff on the ground for you and putting it to work. So
great. And I see one other question that came in here. I want to make sure we ask before we go. Can this run in a hybrid environment, or can it run in the cloud or just on premises?
Yeah, great question. And we usually cover that in in our typical overview, but because Robin is a software-only stack, and we do support the cloud, we do support multiple cloud models, in fact, but we're agnostic when it comes to whether it's running in AWS, GCP, Azure. So we support either, and we support a combination thereof. So we can support the hybrid cloud model, the multi-cloud model. We in fact have a bundle, for example, that is built around MongoDB for deploying across multiple data centers. Those multiple data centers could be consisting of multiple clouds, whether they be AZs or in fact, multiple, again, in a multi-cloud a strict multi-cloud environment. It could be across two different cloud providers. So yeah, that's certainly certainly a good question, and something to note that, and with that, it provides a great deal of portability, right? So containers themselves provide a lot of opportunity for bringing portability to the application, just due to their very nature of binding all the very necessary, libraries and drivers, et cetera, that an application needs, and being able to run that pretty much anywhere, practically. But this extends that portability between on-prem, whether it's running on bare metal or VMs. You can build a Robin cluster with VMs. But whether it's there or running in the cloud, being able to, you take one of these bundles and these applications as deployed through one of our bundles, you can very easily export that out of, say, an on-prem Robin cluster and import that entire stack into a Robin cluster as it may live, in the cloud. So a lot to be said there, actually, around the portability equation. But,
yeah,
so,
great info.
good.
Great info, Rob. I know we've run out of time. I want to make sure that I point out to everyone over at robin.io, there is a free trial edition. You can sign up for that. There's also a community edition, and then, of course, the enterprise edition that we've been demonstrating here on today's event. So make sure you visit robin.io to get the hyper-converged Kubernetes platform and try it out for yourself. Thank you, Rob, for joining us today.
Yeah, thank you, everybody. Appreciate it, David.
And thank you, everyone out there in the audience, for joining us on today's special event. Hope to see you next time. Take care. Bye-bye.